Okay, so we've got some examples to practice. Now, in class, what I would do is I would pause and I would say, you've seen the example, now you guys work all these problems. And because I'm trying to make this like a learning and an active experience for you, I really suggest that you go ahead and pause the video right now and try to work these out. And I do have a hint that the formula mass for all of these are on the first pages. And actually the individual masses are also all on that first page. I said they were coming back, and here's where it is. Okay, so pause the video. No, like really, you want to pause the video and try to do these on your own to see if you've got the idea. All right, so I'm going to go back up and I'm grabbing the NaCl's number. It's right here. That 58.44, and I'm going to make sure I've got the other two numbers handy also, the 22.99. So 22.99 divided by 58.44 times 100%. And if I want to go ahead and do the chlorine, I can say 35.45 times 100%. Okay, so what I'm really saying is, since there's only one of these guys here, we don't have them in there, but like they both are one. What I'm really saying is 1 mole of sodium times 29.99 grams per mole. So now see our moles are canceling of sodium. And then this is the guy where I assumed 1 mole. So this gram per mole, the mole part also cancels, which is great. And then now our gram units are going to cancel because in both cases we're talking about masses. So a percent number should come up with only a percent unit, right? You don't want to have a gram and a percent unit. You got to only have 1% unit when you're doing it. So got my calculator handy. I'm just going to put in 22.99 divided by 58.44, and I get 39.34%. So that looks good. I'm going to go over here, 35.45 divided by 58.44, and I get 60.66%. You'll notice these do add up to 100, which is great. That's my sodium and that's my chloride. Now you could ask a question right at this point. Okay, I have only got two things in there, so what do they have to add up to? I kind of already mentioned it. They have to add up to 100. So once I got him, if instead of doing the math here, if instead what I wanted to say was 100 minus 39.34, that would have worked also. So you can do it that way. If you had three things, you would have to subtract, you would have to have two of the values because you'd have to subtract 2 from the 100. You'll see in a minute what I'm talking about. Not this problem, but the one after. All right, so then we're going to do magnesium chloride. So again, I'm going to zoom this back out, and I'm going to go back up to get that magnesium chloride number from the top. Oh, phooey. It won't stay small. There we go. All right. So over here, our bottom number was 95.2. Our top number is 24.3. That's magnesium. Now, want to be careful not to make the mistake of dropping any of the chlorines. There's 2 of them. So I want to make sure that I'm saying 35.45 times 2. All right, so I'm going to grab those numbers, put in my calculator. 24.3 divided by 95.2 times 100. That gives me 25.53%. And then over here, so I can either plug these numbers in, but since I've only got these 2 elements in here, I can also say 100 minus 25.53. And that'll give me 74.47, which thankfully does add up to 100. You can kind of glance at those. I'll go ahead and throw the numbers in as a double check. If you were on a test, I would also just double check yourself, because you'd hate to miss something like this, because you can already tell the math isn't very complicated and it relates to concept that you've already done. And I'm getting the same exact number in my calculator. All right, so now we have the Na3PO4. And switch back. So I'm going to go back up the Na3PO4 number. It's up here. So Na3PO4 is 163.96. And again, my sodium, my phosphorus, and my oxygen. I'm going to do my sodium over my 163.96. Don't forget that there are 3 of them. My phosphorus, and if you can't remember phosphorus, you can put back up. It's 30.97. Do I have more than one? Nope, there's just one. And then the last one is the oxygen. Don't forget, that one is 16.00 times 4 over 163.96. All of these are times 100% too. I shorted myself there. All right, and come back up. I'm going to zoom back out. So just grab my calculator. 22.99 times 3 divided by 163.96 times 100. You can do this in any order. I get 42. Whoops. .07% for him. Now at this point, I can't subtract to get phosphorus because I've got 3 elements in here. I gotta have at least 2 before I can do the little subtraction trick. So 30.97 divided by 163.96 times 100. And I get that this one is 18.89%. And then, again, if I'm going to do the subtracting thing on this one, it's going to have to be 100 minus 42.07, oops, and then also minus 18.89. Or we can just put the numbers in, I don't know which way you want to do it. 16 times 4 divided by 163.96 times 100. And I get 39.03. This is one of those ones where it's a little slightly off. It's not quite adding up. I'm going to see what I get when I do 100 minus 42.07 minus 18.89. And so this one gives me 39.04 because we subtracted it from 100. Here's what I will tell you is that right here, this was originally a 6 and a 5. So if I just, and that 5 is really close, if I just kept it at a 6, then this being a 04 would work. Again, we aren't getting super picky about this. This is Gen Chem. You are not trying to submit some kind of data for a national research paper. This is Gen Chem. If you get 39.03, 39.04, you get something very, very close, then that's totally fine. And do make sure your numbers add up to 100, approximately. So you don't want them to be like way off. So that's that one. So that's the first math technique. Now we're going to just review a few ideas.